So today we're going to take a look at adding sum and difference angles to our card. And we found the information on page 619 and page 627. And on your index card, you needed to add the cosine of alpha plus beta, and that was equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. So it's important that we know that these are two different angles, and we're going to use values from the unit circle that we've memorized to find the sum of the cosine of the sum of two angles. Well, there's similar formulas for the difference as well. And it's cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. And so those are the cosine sum and difference formulas. We're going to work with these two in just a moment, but before we do that, while we're on page 619 and 627, let's go ahead and add the other formulas as well. The sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha, the sine of beta. Now remember, we're adding these to our library or our index card. Okay, so someone pointed out that the tangent sum and difference formulas were on page 623. So the tangent of alpha plus beta is equal to the tangent of A plus the tangent of B, beta, over 1 minus tangent of alpha times the tangent of beta. And then the last one that we're going to add on our card today is the difference of the tangents. So it's alpha minus beta, and that one is equal to the tangent of alpha minus the tangent of beta. And it's 1 plus tangent of alpha tangent of beta. So aren't you glad I'm not making you memorize all these and you can use your index card? No, I'm too lazy to start over. So I forgot to put in the difference of signs, so let's add that down here. Hopefully on your paper, since you went to the pages first, you put them in order. So the sine of alpha minus beta is sine of alpha cosine of beta minus cosine of alpha sine of beta. So it doesn't really matter if they're not in the right order on your index card, but you should have all of those on your index card so we can work some examples. At number 13 from page 624. And question 13 says the sine of 45 degrees minus 30 degrees. And notice that it has parentheses around there. Well, the idea for the sum and difference formulas is to use angles that we know from our unit circle to calculate the values of items that we don't know, because I have not memorized the sine of 15 degrees. Have you? So you don't have to. But if you can find two angles whose combination, either adding or subtracting, from the unit circle will give you that angle, then you can calculate that value exactly, even without using your calculators. So this unit circle idea was very handy. Okay, so we recall from our index card that when we have the difference of sign, it is sine of alpha minus beta is equal to the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. So in this particular one, we're looking for the sine of 45 degrees. I'm writing down way more than I expect you to do at home, just so that you can see what we're doing. The cosine of 30, okay, so this is alpha, and this is beta, minus the cosine of 45, and the sine of 30. So the beauty of knowing the unit circle is that we now know the values of all of those things without picking up our calculator. So if you recall, knowing that the sine is the y component and the cosine is the x component, we're thinking of 45 degrees. So remember from our poster, that's the orange one. And so the sine of 45 degrees is going to be the square root of 2 over 2 from our unit circle. And the cosine of 30, remember that's the first one, is going to be the square root of 3 over 2. So we need to multiply those two together. The cosine of 45 is the square root of 2 over 2. And the sine of 30 is 1/2. So what we're saying is that when we work these out, you will get an exact value. But if you plug in your calculator, if you have a calculator handy, that will be a rounded answer. So remember, when we multiply fractions and under the radical, this is the square root of 6 because you multiply 2 times 3, and this is 4 because you do multiply the top times the top and the bottom times the bottom. So this is going to be the square root of 2 over 4. So what we have for our answer is the square root of 6 minus the square root of 2 over 4 for our exact value. Okay? So I'm going to pause the video for a moment, and I want you to pick up your calculator and test that out. Is this the sine of 15 degrees? And so I'll give you a moment to do that.